So welcome guys, welcome back to my YouTube channel, and today we are going to discuss the solution for Codeforces Round 943 Division 3. So I was able to solve 4 questions during the contest, and after the contest I solved basically E problem. So we will be discussing problem A to E. So let's dive into solution. So talking about the first question, maximize. Okay, so what this question is saying, you are given an integer x. Okay, we are given one integer x, and your task is to find any integer y such that gcd of x comma y plus y is maximum possible. Okay, so we need to maximize this thing. Okay, so we have given an integer n, we have to find a y in this range such that if we take the GCD of that number with x and add that number, it should be the maximum result we can get. Okay, so everyone knows what is the GCD. GCD is greatest common divisor. Like GCD of 6 comma 4 is 2. That means 2 divides 2 is the highest divisor that divides both 6 and 4. Okay, now we are given a constant for x. X can be in between 2 to 1000. Okay, so we can simply brute force it. We simply brute force it. We will just do what this is saying. Okay, we will run a for loop from 1 to x. Okay, from 1 to x, because y is in between 1 to x. We will run a for loop from 1 to x. We calculate this term, gcd of x comma y plus 1. Okay, and if this term is greater than our current answer, then we will update our current answer and save that y in our value such that this y is giving us the maximum answer. Okay, so we will just directly see the solution. So this is the solution. Okay, so we will initialize our answer to be 1 and value is also 1. Okay, initially both are 1. Now we need to maximize this answer, and for what value we are getting that maximum answer, we need to store here. Okay, so I ran a for loop from 1 to n, that is y. Okay, because the range of y is 1 to n. So so n means x. Here n means x. Okay, so we calculated this term gcd of n comma y plus y and saved in a variable. If this value is greater than our current answer, so this y can be our possible answer. Okay, so we will update our answer by x and save that value, save the y in the value. At the end we will print the value. So that is the that will be accepted. Okay, so I guess testing is going on, I guess. So preliminary testing. So but it is accepted. So moving on to next question. Here it is showing accepted here in queue. Okay, so next question is prefrequence. Okay, so we will see what this is. You are given two binary strings a and b. Okay, everyone knows what is a binary string, which contains only 0 and 1. Okay, your task is to determine maximum possible number of k such that prefix of a string a of length k is a subsequence of string b. So many of you might get confused what is the statement is trying to say, so I will explain it. Okay, we need to find a number. Okay, that is clear. We need to find a number k such that the prefix of this length of a. Okay, so we need to find a prefix of length k in a such that that prefix is also a subsequence in b. Okay, now what is the subsequence? I will show you by taking an example. Okay, subsequence means like the order will remain same, and subsequence is basically here it is given a sequence of if we delete some numbers from B, so we will be able to get the prefix of length k. Okay, so let's understand why this is. Let's understand it. I know theory by telling things it is not clear, so we will do this on a board. This is A and this is B. Now we need to find a prefix. A prefix. So prefix, it must be continuous. Okay, it must not be non-continuous, like you are taking this one, then this 0, this 1. So this is not allowed. That is subsequence. You need to take a prefix. Like prefix means this. Suppose this is a k and you need to take a prefix. Okay, so this, and you need to check whether this prefix is present here or not. So you can see 100 is not present here, 10 is present. So we will take this prefix, 1 0. See, 1 0 is present here. If you delete this 2, we get 1 0. If you delete this 2, we also get 1 0. So 1 0 is present. Okay, so what is the length of this 1 0? 2. See, minimum length is 1. Minimum length is 1. See, minimum length means 1. If we take 1 is always present here. Okay, but we need to find a maximum prefix that is present here. So maximum prefix is 1 0. See, 1 0 is present here. So maximum length of that prefix is 2. So answer is 2. Answer is 2. Okay, we will take another example. So this, the answer is 3 here. Okay, so we will take this example. Okay, so what can be a maximum? Okay, you try to think. So this is A and this is B. Okay, if we take 1, it is always present. If we take 1 0, 1 0 is always 1 0 is already 1 0 is also present, 1 and 0. If we take 1 0 0, 1 0 0 is also present. Delete these two numbers, you will get 1 0 0. See, order must remain same. You cannot take this. See, here is also 2 zeros and single 1. Okay, but order should remain same. 1 should be followed by 2 zeros. Okay, so this 1 and this is followed by 2 zeros in front of it. So order should remain same. Okay, that is a subsequence. So see, what will be the answer for this? 3. Because if we take this point 3 and this is the prefix, this is the prefix. So this whole prefix is present in this string. So what will be the maximum length of k? Maximum length of k will be 3. See, maximum length of k will be 3. Okay, so now you understood what this question is trying to say. Now what will be how should we approach this? Okay, so these two tags are perfect to define this question. We need to apply greedy approach and two pointer approach. Okay, now we will understand how this approach came. Understand how? Okay, see, we know one thing that we cannot jump here to here because we need to find prefix. So we need to keep taking this part. We need to keep taking this part and we need to take prefix. So we cannot take this middle part. Okay, we cannot take this middle part. We have to start from first element and go till k such that is present here. Okay, so we need to start from here only and we need to go one by one forward in A. Okay, so that is clear for A. So we will have one pointer I which will traverse A. Okay, now we will have another pointer J, yj. See, we need to just check are this whether the numbers which are coming here are present somewhere forward, because we cannot see like it if uh, I was trying to say, like if we are going forward here, so we also need to go forward here. So if 0 are present, if suppose the string is 0 1 1 0 1, okay, so we suppose 0, here is also 0, okay, so we, so here is, so suppose we are here, okay, we are here, and now we move forward our j to here. So see, but what we need a 0 and we got 1. See, so a 0 is present here on the back side, but we cannot take that. We have to take everything which is forward only. We can't go backward. See, we can go backward. We only need to go forward, and the number should maintain their orders. These two things brought this approach of two pointers. So we will keep two pointers for A and B. We will check whether I and J are matching. If they are matching, we will increment I and we will increment J always. Okay, and whenever they are matching, we will increment I. And at the end, wherever I stops, that is our the maximum length. Okay, see, we will try run it here. Initially I is equal to 0 and J is equal to 0. They are matching, we will increment both. I, J here, I here. They are matching? No. We will increment J. They are matching? Yes. We will increment I. We will also increment J. They are matching? No. We are increment G. Now they are matching? We will increment both I and J. Now string is finished. I is at 3. I is at position 3. We will print 3. Okay. So this is how the solution solution came. Now let us just see the implementation. Very simple implementation. Taking the input, initializing two pointer with 0 0, running a for loop, a while loop, and if they both are matching, we increment I, and at the end we print I. Okay, so so this is also matching. Now see, now coming towards the third problem, assembly via reminders. So you are given an array x2 x3. See, you are given an array x2 x3. First element is not given. Okay, so we need to find an array from a1. So one extra element should be present here. Okay, so your task is to find an array a1 to an where. See, simply what you have to do, you have to print any array in the universe. You know, you can produce, you can write, but it need to follow just two conditions, only two, not more than that. Okay, so first condition is what? AI should be in this image. So this is the garbage condition. We don't see we don't see we don't see such conditions. We will jump on main condition. This is the main condition. Okay, so ultimately you need to focus on just one condition. You can print any array. Okay, so what this condition say? Xi. See, we are given this array x2 up to xn. So xi should be equal to ai mod ai minus 1. Okay, so we will start from second element and we will check whether the mod of that second element of current element with its previous element is equal to I or not. Okay, so we will understand this by taking an example. Okay, so this is an example 241, and here we are the solution. See, there can exist multiple solutions, but we are discussing first this, then we will discuss the another solution also. Okay, so see, this is xi, this is a. Now see, here is 5. Okay, so xi should be equal to what? 5 mod 3 2. this should be equal to what? 4 mod 5. 4. This should be equal to what? 9 mod 4. Okay. So this is the solution. This is one of the solutions. See, this is one of the solutions. From this array, we can derive this array. From this array, we can derive this array. Correct? Okay. So now the question is, how we will generate this array? Okay. For that, you need to understand modulo, how modulo works, what is its meaning. Okay, so I will tell. See, if I give you number 2, okay, and I give you number 3, and you need to find a number x such that x modulo 3 is equal to, you need to find this number. Okay, so see, this is what we are going to do here. See, we have to assume this first number because we are given 3 numbers x2 to xn. The first number we have to assume, and from this first number we are given this 2, and we need to generate this x such that x modulo 3 should be equal to 2. Then when we generate this number, then we need to generate this x such that x modulo 5 should be equal to 4. See, this is what we are doing. Okay, so you need to understand how this works. Okay, so when you are given this type of solution, you need to convert this to congruent. See, x is congruent to 2 mod 3. Okay, see, if we are dividing this number by 3, we are getting remainder 2. Okay, so if we divide this number wait a minute. Okay, so forget it. So see, what is the meaning of this? Meaning of this is like the x is such that when x is divided by 3, it is giving extra 2. Okay, it is giving extra 2, right? It is giving extra 2. That means x is greater than equal to 2. You agree? X is greater than equal to 2 because so okay, it is giving extra 2. So what different numbers we can generate such that, so what are the different numbers that can take place of x? So see this carefully. Can we write x as 3q plus 2? We definitely write, because x is a number such that when we divide that number by 3, so the part which is divisible by 3, that gets consumed and the extra 2 part is remaining. So see, the part which is divisible by 3 gets consumed and extra 2 is remaining. Okay. So for simplicity we will keep q is equals to 1. We will take q is equals to 1. We can take q equal to anything. We can take 0, but then here we might face problem. Okay, so we will not take 0. I mean, we will not able to get the correct answer. Okay, so we put q equal to 1. So the minimum possible value of q we will take is 1. Okay, so what is x? X is 5. So see what we did here, we did x is equals to 3 plus 2. Okay, what we did here, x is equal to 3 plus 2. What is 3 plus 2? This number 3 and plus this number 2, we get this number 5. Such that, see, this is one of the solution. Now we will try to generate the solution from our logic. So see, if the first number is 3, second number will be 5. What will be the fourth number? Add this 5 with 4. What we will get? 9. Add this 9 with this 1. What will we get? 10. Now check. Are we able to generate this from this array? Okay. So 5 modulo 3. 5 modulo 3. 9 modulo 5. 4. 10 modulo 9. 1. 2 4 1. 2 4 1. See, this works. This works. But there is one problem. This will, like, we need to find what will be the first number. Okay, what will be the first number that we can take? See, we cannot take any number. See, we cannot take 3 every time. I will tell you why. Take this example. Take this example and you will see why we cannot take 3 every time. I guess I have a wrong answer, so I must have taken 3 as my first element every time. See, I have taken 3 as my first element, so it will give the wrong answer. I will show you. Take this example and take first element as 3 and do the same thing. Do same thing. What is 3 plus 4? 7. What is 7 plus 2? 9. 9 plus 5. 9 plus 5. 14. 14 plus 1. 15. 15 plus 2. 17. So this will work. But see, 7 modulo 3 is not equal to 4. Rather it is equal to 1. 7 can be written as 2 8 2 3 plus 1. Remainder is 1. But we want 4. This will fail. Okay, so now we understood this will fail. Now we need to think what we should put at the first place. Okay, so see, the modulo property. Okay, the modulo property you do. So suppose you bought any number n with 3. What you will get? 0, 1, 2. See, so you cannot go beyond 2. You will be in this range only. You take any number, you take 100. 100 modulo 3, 1. You take 99. 99 modulo 3, 0. Like you take any number n, you will be in this range only. So, if we are taking modulo, so we need to make sure that the maximum number which is present here is also able, will be also able to generate from the our sequence. So what we can do, we take the maximum of the array plus 1. Why this plus 1? I will tell you why this plus 1. Okay, so what is the maximum? 5. Okay, 5 is maximum. So if you take any number modulo 5, what will be its range? 0, 1, 2, 3, 4. Where is 5? You are not getting this 5. We will add 1 to it. Okay, we will add 1 to it. So now we will get 1, 2, 3, 4, 5. See, all number in this array we will be able to generate. At least we can generate this number. If we take 5, we will not able to generate 5. How we will be generating 5? Okay, so that's why we will take maximum of the array plus 1 and do the same logic. Okay, that's what I did here. Oops. 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 I get this. You see, I take the maximum array plus 1 is my first element and just added the previous element plus current element and just printed the answer. So that was it. Now let's see the fourth question. Fourth question is permutation game. I will open this here. So that's not the problem next time. So okay. So permutation game. What is this permutation? We have two players, Bodia and Sasha. They found a permutation. They describe what is it. So we all know what is a permutation. It is a random arrangement of the number from 1 to n, and the number should be unique. Here 2 are repeating, so this is not a permutation. Okay. So we will focus on the main point. Okay. This is the game they are playing. Okay. So there are k terms. Okay. So they play, suppose 5k is equal to 5, so they play 5 times. Okay. There are five times they play. First time someone wins, second time someone wins, and then we need to find who wins. So they play k turns and simultaneously. Okay, they will not do like random, like I will play first and second also I play, then third also I play, then fourth you play. No, they play simultaneously. Okay, alternative. Now this is the important point. If what is the rule of the game? If the current position of player is x, so we are given the current position of both the player. Okay, we don't need to decide it. We are given the current position, from which position Bodia is starting and which position Sasha is starting. Okay, we are given this. Okay, so suppose the current position of player is x, so his score is increased by x. Okay, suppose Bodia is standing at second position and Sasha is standing at third position. Initially both score will be 0. Okay, after one turn, what will happen? Bodia's score will increase by a of 2. Sasha's score will increase by a of 3. Now, after playing each move, the player will have choice. What choice? Either they can stay at their current position, or they can move to P of x. Okay, there we have choice. Now, when this statement we read, the first thing that came to our mind is D, because we are given choice. We are given choice that we can either stay here or move forward, and in this way we need to find the maximum points gained, right? That is what DP does. We discover all the possible paths and find out the optimal path. Okay, so you cannot apply DP. The constraints are not like good. K is 10 to the power 9. Program will crash. 2 into 10 to the power 4 n. So DP is not valid. So what we will do? Okay, what we will do? See, first we will understand by taking this. Okay, so this, what we are given, nk pbps, this is n, this is k, this is pb, position of Bodia and position of Sasha. Position of Sasha, this is I guess array A, array P, and this is array A. This is array P and this is array A. So see, initially body is starting at 3. Okay, so body is standing here. Oh, sorry. Okay. The body will get this point. So after one round, we need to play 2 turns. So after first turn, what will be the score of Bodia? 5. Because Bodia is standing at third position, so she will get A of 3. And Sasha is standing at second position, so she will get 2 points. Now, now in the next turn, both will have choice. Either they can stay at the second position, at their respective position, or they can move P of their position. Okay, so suppose Sasha wants to move at another position. Where will Sasha can go? So Sasha is standing here. So P of 3. P of 3 means 2. Sasha will go here. Okay, Sasha will go here. So that means Sasha is getting less points than her current position. So why would Sasha go there? Sasha will stay at her place and she will take 5 points. Now it's Bodia. Now it's Sasha turns. Now what Sasha does? Sasha is standing at second position. So second position, P of 2 is 1. That means she can go to first position. Okay, now Sasha is standing here. So Sasha will definitely go here. She is getting more points here. She was getting 2 points first. Now she is getting 10 points. She will move there and she will get 7 points. Now the game is over. At the end, Bodia has 10 points. Sasha has 9 points. Who will win? Bodia. Bodia will win. Bodia will. Bodia wins. In such a way, we have to do everything, do this for everything. Okay. So, what? How can we go? Okay, see, we are given k turns. We are given k turns. K turns, right? Now see, size of this array P and A are limited. So, okay, size is limited. So there are 100% possibility, 100%. If we have some k, suppose we have 4k, 4 into n, where n is the size of this array. Suppose we have 4n. So we have 100% possibility that we will go on the same path again and again. What do I mean by that? Okay, now we will see. Suppose Bodia is standing at 0, right? Now where will she can go? She can go to P of 3. P of 3 means, okay, she can go to 2. Suppose she wants to go, wants in position again. Where will she go? P of 2. P of 2 is 4. See, now she is standing at 4. Now she wants to change her position again. P of 4 is 2. So see, she goes back again to position 2. Now this will repeat. Okay. So this is the redundant part. We don't have to do this. Okay. We will just find the result in this part and we will skip this remaining part because it won't matter whether you have 6 and 12 or you have 12 and 20. It won't matter. Ratio remains same 2. So it doesn't matter, like it is it will not make any sense. Calculate the remaining part same part again and again because the ratio will also always remain same. Okay, so we will move both the players wherever they can move, and if they came back to the position which is visited again, we will stop there. Okay, and we will store every position in an array, like at what position they can go. Okay, so we will do this for Bodia and we will do this for Sasha. Now what will we do this after this? So see, after doing this, there is small, there is a very a small trick to solve such problems. What kind of problem? When it is given that either they can stay at current position or move forward. Okay, you don't have to do anything. I will show you the code. You will understand it. Uh, like you will understand it. What I was saying. Okay. So see, here I converted to one base index into zero base index, and I keep a visited body and visited what Sasha. While the current position is not visited, we keep going. We append that position, we mark that position true, and we move our position to P of P. We will do same thing with Sasha. Now see, initial cost of both the player is 0, and this is the overall like final cost, which is the optimal cost. Okay. See, this is I was trying to say. Okay, either you can stay at current position and take the current points. Okay, you can take current points, or you can move forward. So okay, CSP, like the points which you collected this far, like the points which you collected, suppose we have a turn k is equals to 1 2 3 4 4 turns. So suppose we are standing here. Okay, so either you can stay here only, or you can move forward. So if you move forward, and if you take all the points that are forward to it, so how it goes, this is 2, the total length is 4, the current cost is c. So how much is remaining? 4 minus 2, 4 minus 2c, k minus i into current cost plus the overall cost. So this is the small trick that you can, like if you don't know, you can see here. If many problems, it will work. Okay, so we will do the same thing for Bodia, and we will do the same thing for Sasha, and at the end, whoever have, we will just compare and print it. Okay, so this will work. This is the E problem. I solved it, but I saw like someone. So after the contest, I was able to solve this, and like I saw the solution here, like in standings. I saw the solution. So I will show you. Now you will not able to see. Yes. Now it is under testing, so you can just check it here. You can just take it, and you will like understand it. So what happened? We will go here. This is the solution. Like you can check out like, or you can see watch the read the question and just check out. You will understand it. So okay, I will tell you. You are given an integer n, and you choose n cells x1 y1 x2 y2 up to xn y. You can choose any cell, okay, in this n cross n grid. Okay, it is always a square matrix. So the one base indexing. So here is what we say H with a set of distinct Manhattan distances. Okay, so we need to connect such points with the distinct Manhattan distances. Manhattan distances is x1 minus x2 and y1 minus y2. Okay. So see, we have 3 cross 3. 3 cross 3. So we take these 3 points. So what is the Manhattan distance? Here is the explanation of Manhattan distance. One, we take Manhattan distance of this. This 2 minus 2, 1 minus 1. 2 minus what is this doing? 3 minus 3 plus 1 minus 1. 2 1 2 3 3 1. Leave it. Are we able to hear our own? See, here it is. Manhattan distance between these 2 points. 2 minus 2 is 0, 1 minus 3 is 2. This and this one. 2. This and this point. Three, right? This is 1. Oh, sorry, 1. So see, you are able to get 3 distinct Manhattan distances. Suppose we get something like 2 to 1. So this is the distinct are 1 and 2. So this is not the maximum. We need to find the maximum such that the distances. We need to maximize this h. So the number of distinct element in that set should be maximum. Okay. So what will you do? See, simple. I was not able to recall this solution in my mind at the time of contest, but it is very simple. See, you need to find distinct solution, right? So what? Suppose you have 3 cross 3 matrix. What are the distinct solution you can get? 0, 1, 3. Okay, how will you get that? 1, 1, 1, 2, 1, 3. Okay, you will get this, and yeah, that's it. So here, what is the difference between this and this? 1, 2. This is also 1, and suppose you take here 3. So this is between this is 1. This and this is 4. This and this is 3. Yeah, see, you get 3 distinct values. Okay, so simply you have to do is just print 1 comma n. Okay, just print 1 comma n. At the end, if n is greater than 3, do this. Print the last element. That is the solution. 1 comma 1, 1 comma 2, 1 comma I from 3 to n minus 1. It is n minus 1. 1 base indexing. Now if n is greater than equal to 3, just print nn. Okay. That was it. So these are all the solution. I hope you like it. So keep coding, keep solving problems. Bye bye.